Welcome. In this video, I want to give you an introduction to some of the basics of hypothesis testing. In particular, we'll talk about the language of hypothesis test. So first of all, it seems like we should have a definition for hypothesis. So in statistics, when we speak of a hypothesis, it is a statement regarding a characteristic of one or more populations. The characteristics that we talk about, usually these are parameters. So for instance, we'll look at statements about the population mean, which is mu, or the population proportion, which is p. And so we have some theory about one of these parameters, and we want to be able to test those theories. So that's where hypothesis testing comes in. So a hypothesis testing is a procedure based on sample evidence and probability used to test statements about a characteristic of one or more populations. So we're testing statements or theories about these parameters, such as mu or p, the population mean, or population proportion, or some other characteristic. So the way that this works is we have two kind of opposing hypotheses. One of them we call the null hypothesis, and for this we use a symbol H with a subscript of 0, and we call that H naught, N-A-U-G-H-T, H naught. And this is a statement that the characteristic is unchanged, or we can say equal to, or that the status quo is maintained, and the opposing hypothesis is called the alternative hypothesis. And depending on where you look, the symbols can vary somewhat. Some will use a subscript of 1, so this is H with a subscript of 0, this is H with a subscript of 1, and you would just say H1. Elsewhere you may see a subscript of alpha. So alpha for alternative, you can think of that as being for alternative. There's another meaning to this alpha though, but this is the research hypothesis. And often, this is the working theory that something has changed or is different from what might be accepted or assumed, or this status quo. Now, it's important to know that this is assumed true, and this is what we're trying to find evidence of. And so when I'm saying that this is the status quo, this is the assumption that's out there in the universe right now. And as a research, you might have your own theory, something that goes against the grain, and that would be your alternative hypothesis. So when we are writing these, we write them in pairs. So the null hypothesis is always followed by the alternative hypothesis. And I want to give you the three options that we have here. So the first one, we could say that this parameter, for instance, the mean or the proportion, equals some set value. That would be a statement of a null hypothesis. And we might have a research hypothesis. The alternative hypothesis, or H1, just says that the parameter is something other. It differs from this value. So oftentimes, when you're looking for the language that would indicate that you should set up a alternative hypothesis with a not equal sign, you might see something like language like has changed, or just differs. Or simply, is not equal to. Another option, and the change here that you're seeing in each of these is always in the alternative hypothesis, in the H1. Here you're seeing a does not equal statement. Here you're seeing a less than statement. The parameter is less than some value, and here the parameter is greater than some value. So we can have not equal to, less than, or greater than. So it's important to pay attention to the way we set up these alternative hypotheses because we actually end up categorizing these as different types of tests. The test that results from this statement of not equal is called a two-tailed test. And the test that results when we have this less than statement in the alternative is a left-tailed test. And when we have a greater than statement in the alternative, it's a right-tailed test. So that's completely determined by this symbol that's in the alternative hypothesis. Whether it's a not equal to sign, that's the two-tailed test. The less than sign would be left-tailed, and the greater than is right-tailed. So notice that in each of these, in the null hypothesis, the statement is that the parameter equals some value. So that stays the same in all of these. The change is in the alternative from not equal to less than to greater than. So when you're trying to decide, you might think to yourself, as far as how to set up the alternative, if you were to start out a sentence to say that a researcher wants to, or if you're the researcher, you could say, I want to test whether, and so something like the population mean is greater than 100. So in this case, I want to test whether the population mean is greater than 100. When I'm setting up my two opposing hypotheses, H0 and H1, the alternative here is that the mean is greater than 100, and the null hypothesis would be that the mean equals 100. So that's how that would work. All right, so the first step in conducting a hypothesis test is to just set up these hypotheses. So we can, if we're talking about a process here, we're going to make a statement. That's our hypothesis. So this is, H1. And then we're going to go collect some evidence. Usually this is in the form of a sample data. And then we'll analyze the data to assess the plausibility of this statement. So does this seem likely, based on the evidence that we find in the sample data? So after we analyze the data, and when we're thinking about that plausibility, we have to make a decision. And we have two options. We can reject the null hypothesis, that's H0, or we say that we fail to reject H0. So notice that both of these decisions are in terms of the null hypothesis. So even though when we're setting this up, and we're thinking about how we set up this one, this is when we're saying we want to test whether this is true. Nonetheless, when it comes time to make a decision, the decision is in terms of the null. You can reject or fail to reject. And what you have to keep in mind, though, is that there's always a chance that we would make the wrong decision. So you could reject the null hypothesis when, in fact, it's true. Now, that would be an error, and we call this a type 1 error, when you reject the null hypothesis when it's true. Now, if you reject the null hypothesis when it's false, that's a good thing. You've made the correct decision. Now, the other option, as far as the decision from the test, is that you could fail to reject the null hypothesis. If you fail to reject and the null hypothesis is true, again, you've made the right decision. That's great. But if you fail to reject the null hypothesis when the null hypothesis is in fact false, this is an error, and we call this type 2 error. Of course, we would like to minimize the chance of these errors. So in hypothesis testing, the probability of making this type 1 error, that's rejecting the null hypothesis when it's true, we can measure that. That's using the level of significance. The symbol that we use is the Greek letter alpha. So that level of significance is the probability of making a type 1 error. The probability of making the type 2 error is called beta. So that's the Greek letter B. It's the probability of a type 2 error. And you should know that these things have an inverse relationship. So if your level of significance goes down, then beta will go up, and vice versa. If alpha is increased, beta will go down. So that's how they have an inverse relation. All right, so those are some of the basic terms that we use in hypothesis testing, and how do we set up. We're going to make a statement of our hypothesis, look for some sample data, analyze the data to see about the plausibility of our hypothesis, and eventually we're going to have to either reject or fail to reject the null hypothesis. We want to keep in mind that there's a chance we'll make a mistake. We could make a type 1 error, which is when we reject the null when it's true, or type 2 error, we fail to reject the null when it's false. The likelihood of each type of error can be measured. This is measured by alpha, the level of significance, and this is beta is the probability of a type 2 error. In the next video, we'll look more into how we actually analyze the sample data in order to make this decision. All right, I'll see you then.